I'd previously written some functions into the borrow, some methods into the borrow, some expressions into the borrow function. But it was when I got to this part that I knew that I was doing something wrong, and I had to do some research, and I was able to kind of figure out what I was doing wrong. So I've addressed what I was doing wrong by, showing you this example here, which is what we're going to implement. So the first point of call is we know this amount in USD. I think I should probably say this. This is amount in USD, amount and stable token. Yeah, actually, let's call it amount and stable token. All right, stop, stop. Good. All right, so this is our borrow function. We do our address check. We check if the amount of stable token is greater than zero, and we need to confirm that the loan to value is, set greater than zero as well. So here we get the price of the collateral token asset, which is the asset that we're borrowing against. All right, and if the asset price is not greater than zero, then we have an invalid price. So let's begin. The very first thing is, um, I think what we should do is let's write a view function. All right, the function is called estimate. Um, so we want to estimate this amount, this value provided by Alice. So estimate value required for loan amount, okay. All right, estimate value required for loan amount. I think that's okay. Not a good name. I think I've just seen a better name I can use. Let me preview maximum borrow. So the idea is, um, if Alice wants 250, but preview maximum borrow is not a good definition to. Let's call it mm, estimate value needed for loan. Okay. Now, what does this do? It's similar to, okay, it takes in viewing 256 amount in stable token, external view returns, and it returns U in 256. Yeah. I'm going to make this public actually. Why? Because sometimes the person might need to call this just to know, you know. So we're going to make it a utility function. Now, when a person is trying to estimate the amount needed, we need to do something like uint 256 value is equal to, remember that what we did here, we did 250 divided by the loan to value. So we're going to do amount in stable token divided by, what's the loan to value? Loan to value ratio, okay? Now, obviously, the loan to value ratio must be set. Okay, so that's a necessity here because you don't want to divide by zero. Okay, now remember that this is a big number and this is also a big number, and I've told you before that when you're dividing two big numbers, you kind of have to multiply. All right, so this is the amount in stable token divided by loan to value ratio. So because we're dividing, we need to multiply. This would preserve our, okay, good. So we return value. Okay, that's what we need here. Now, we're going to write another function. This function is estimate units of collateral needed for loan. And similarly, it takes in this, but it also takes in address of collateral token. All right. And obviously this is external, actually public view returns U256. Good. So what we're doing now is we want to do this calculation. Yeah. So let's get that sorted. Estimate units of collateral needed for loan. The first thing is we need to estimate the value needed for loan. All right. So U256 total value required is estimate value needed for loan. Then you pass in amount in stable token. Okay. All right. Now that we know the total value required, which is this number, we need to get the price of the asset so we can divide it, accordingly. So the price of the assets will be, let's just come here. We're going to call our oracle. Get asset price, this one. Okay. Now, remember that we're going to do a division, right? But before we do a division, we need to make sure that everything is tip-top, because I already showed you that if you divide directly, you're going to be under collateralized. So we're just going to over collateralize a little bit. So we need to do this price of the assets minus 1. I mean, we're just going to implement it anyway. So we need to do something like A plus B minus 1 divided by B. That sort of thing, yeah? Where the denominator is B, and I'm going to check right now, because sometimes what happens if the price is less than 1, in which case you'll be having 1 minus B or something like that, so I'm going to need to verify that. Let me see. Okay. I think similarly, we're gonna have a similar problem here actually, because when we're multiplying this and we're dividing this, there will be some leftover amount, so we need to handle that as well. So let's do loan to value ratio minus 1. Okay, I'm going to double check something after this. I'm going to double check something. Before I do, I'm going to double check something. So let's see. So we're going to do A plus B minus 1 over B. So in this case, it's going to be total value required. So we're going to have U256 units needed is equal to total value required, which is this, plus total value required plus B minus 1, that's asset price minus 1 E18 divided by asset price. Okay. All right. Yeah, so let me do a quick check and see, confirm what happens if the asset price is less than 1, in which case this will be a negative number, so we need to handle it. Okay. Hi guys. So I figured out what I was worried about. I was worried about this relationship, and I think there is a simple way for me to handle this. Yeah. So I'm going to write an internal function, which I'm going to use to refactor everything. It's called ceiling division. And it's going to take in two values, which is the numerator, doing 256, and numerator, doing 256, denominator, and it's going to return, it's going to be an internal function, a pure function. A pure function is a function that does everything within itself, doesn't use anything externally, and returns uint 256. So the relationship we're trying to model, if you remember, is return A plus B minus 1 divided by B. This is what we're trying to model. Okay, now we're going to be using ceiling division here and here. So first of all, we want to do ceiling division here. Okay, so we're going to say ceiling division. What is our numerator? The numerator is the one sec. Sorry, one sec. This. Oh, sorry. Good, sorted. So here we're doing a ceiling division, which is, this is the numerator and this is the denominator, so we need to also handle this. So yeah, we come here and we do ceiling division. Numerator is the amount in stable token. The denominator is the loan to value ratio. Okay, now we need to make sure that this value is standardized, because we're doing a division. We need to the numerator needs to be of a higher it needs to be multiplied by 1 E18, this constant. Remember that we talked about this, that whenever we're dividing, you multiply, and when you're multiplying you divide by 1 E18. So now in doing ceiling division, we get the value, which rounds it up for us as well, because here when you do, imagine this wasn't 50%, imagine this was like, let's say 65% or some other kind of number, it would give you something that has a decimal point and you need to round up, so really that's how we're doing it here as well. So yeah, we've done the ceiling division here. Now we also need to do a ceiling division here. Okay, so the ceiling division that we're doing here is, so the numerator is total value required multiplied by 1 E18, obviously, and the denominator is going to be the asset price. Okay, And honestly, we don't need to store units needed. We just need to return this value. Okay. So now that we've done it, I've established this relationship. I showed it to you here. We've written a helper function, and then we've used our helper function within our calculations. Okay. So now we know the units of tokens that are needed, right? So let's come back to our borrow function. Boom. So we know we have the asset price, we have all the things that we need. The very first thing that we need to know is when this person is making this borrow, we need to know if they have enough assets that's to cover their loan. And to do that, we need to call this function, estimate units of collateral needed for loan. Okay. So let's come to borrow uint 256 units of collateral needed. All right. Boom. And we paste. Okay. And this value takes in two things. I think amount and stable token, as well as collateral token address. Okay. All right. Good. I actually find that we do not need this anymore because we calculate this. We get the asset price internally, using this. Where is it? Okay, so we can maybe comment this out, and then when we're done, we'll probably delete it. So we have the units of collateral needed. Now, the biggest question that we need to ask is, does this user have this amount of collateral? So we need to require that the user balance which is this, the borrower info message or sender, borrower asset available, collateral token address must be greater than or equal to units of collateral needed, else insufficient collateral available. Boom. Okay. Now, if they have sufficient collateral available, what we need to do is we need to reduce the collateral available by the units of collateral needed. So because they're technically not borrowing against everything. So imagine somebody has 1,000, but they only borrow like 100, and technically the 100 means that if at an LTV of 2, of 0.5, that means they need about $200 worth of assets. Let's assume that the value of the price of the asset is 1 to 1, so $200 is the right amount. So it means that we need to take 200 units from their 1,000 and then leave the remaining 800 behind. So we need to reduce the amount of available assets by the units of collateral needed, just in case they decide tomorrow that they want to borrow some more. Okay, so we do that, but at the same time we need to also note what they have borrowed. So we need to increase the amount that they borrowed. Now previously I added a mapping which tracks the total amount of borrowed assets. So that's what we're going to do here. We're going to increment this here by units of collateral needed. Boom. So, and then we're going to increment the active loan count, and then we're going to then do a transfer of the assets, because we have taken from it. So let me just go over it one more time. We don't need this anymore, so I can delete it. So imagine someone has, let's come to our Excel sheet. Imagine someone has the value of their assets is $1,000. This is their collateral assets. Okay, value of their total collateral assets is 1,000. Loan request is 100. okay, at an LTV of 50%, how much should they hold? How much collateral value required for LTV is 100 divided by 50. Okay, assume price is $1. Okay, so that means that this is 200 divided by 1. Okay, so we know we need to deduct it. So what's their new balance when they take the loan? It would be this minus this, 800, and then their loan balance is equal to 200. Okay, so this is exactly what we just did, nothing weird. So we come back here. So let's clean up our function. We do not need this, boom. We do not need this, boom. Yeah, we do not need this, boom. Okay, good. All right, so I have managed to clean up our function, and obviously there is one caveat that I need to point out, is that all the values that we're working with are in 18 decimal places. Okay, and I am going to make an addition off screen that ensures that like the the numbers are always to the 18 decimal places, because all the operations that we're doing here, we are handling 18 decimal places. Very important. Okay, so I'm just going to do a video for that. Be the only time where I actually quickly run through like a helper function without breaking it down. So what we're dealing with here is we're trying to upscale a number to 18. If the decimal number is equal to, if the decimals of the token is equal to 18, do nothing. Otherwise, if it's less, you want to find out by how much is it less. If decimal less than 18, you want to find out by how much is it less. And then if it's less by maybe let's say 6, so you do 18 minus 6. So you know that you need to scale up by 12. But on the off chance that it is greater than 18, you want to scale it back down. So it's maybe 25. So 25 minus 18, and then you chop out some zeros. Okay. So similarly, we're doing the reverse here. So this is to 18, this is from 18. So we are shrinking the number down here. So these are just the same thing, but they're just inverse of each other. All right. So now we're going to be using this in our calculation to in our estimation values here, so that we can actually handle some collateral assets that have weird decimal numbers. For us to do that, there's one thing that we need. We need a standard called IRC20 metadata that gives us access to the decimals on a stable asset. So let's get on a collateral asset. Let's get IRC20 metadata from, I think it's Open Zeppelin. Contracts, interfaces, IERC20 metadata. So we're going back. Okay, cool. So now what are the things that we need to do here? The first thing is we need to normalize the borrow. Okay, so here let us get the decimals for the stable assets. Okay, uint 8 decimals for stable asset is equal to, here we'll call, hold on a second. Okay, there is a function that I need to write, an internal function. So function here, this gets decimals. It's not like I can't actually, let me not write the function. Let me do this. So decimal for stable assets. We're going to use that interface IERC20 metadata. We're going to wrap our stable assets, which is our loan assets, and then we're going to get the decimals. Yeah, boom. All right. Oh, explicit conversion. Boom, 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 boom. So I'm going to wrap this here in address. Okay, cool. So we have decimals for stable assets. Now, what we're going to do next is when we are estimating what the borrow should be, we are going to scale. So let's scale this value to 18. Okay. Uint 256 borrow value scaled to 18. We're going to do to 18. We're going to pass in amount in stable token. We're going to pass in the decimals for stable assets. That scales us up. So we're going to now run our operation based on this. So that way, this is valid. Otherwise, it would be throwing off a lot, because of this 1E18 that we're doing here. Okay, so we're standardizing this borrow value 1E18 sorted. Okay, now that we've done that, we need to do the same here again. So looking at the estimate units of collateral needed for loan, we need to also handle any scenario where we know that internally this already scaled this. All right, so we need to estimate the units of token of collateral needed for loan. So the collateral token, we need to estimate as well what the decimal places is. So let's call we've done our DV. So instead of, let's change this to uint 256 units needed. Okay, so we have units needed. Let us scale that units down depending on the number of decimals for the collateral. So your uint 8 collateral decimal values is equal to IRC metadata collateral token dot decimals. Yeah, okay, and then this is going to be, we're going to be scaling this from 18 to whatever it should be. Now if we already know that if it's going to be 18, it's not going to do anything. Because like if it's equal to 18, it's just going to return itself, so this only handles it in an event where it's not 18 decimal places. So in that case, we need return from 18, and we're going to say the units needed is, so let me specify that this is in 18 decimal places. Units needed in 18 decimal places, and then collateral decimal value. Okay, yes, so we just managed to clean up our entire function, and yeah, this sets us up neatly for the borrow. So our borrow function is complete. We'll be moving on to the repay function next.